Hi everyone, and welcome to Backer Breaks It Down. In today's episode, we are going to simplify radicals, focusing on square roots. We're going to look at two methods how we can do this, okay? So let's get started. So one way that you can simplify a square root is to use the multiplication property of square roots, okay? So basically, the product of the square root of a times b, okay, is equal to the square root of a times the square root of b. So look at what they're saying. They're saying just multiply the two insides, those two radicands, a times b. Just do that. You still have the square root, that's still there, but you just simply multiply what's on the inside, okay? And so here they're saying, like, if you take the square root of 9 times the square root of 6, this equals the square root of 54. Okay. If you've got numbers inside and outside of your radical symbols, you're going to multiply the insides with the insides and the outsides with the outsides. So in the second example here, we have negative 2 root 5 times 3 root 2. So they multiplied the outsides together, 2 times 3, well, negative 2 times 3, they got negative 6. And then they went and they multiplied the insides together. So they went square root of 5, square root of 2, square root of 10. Okay. So when you go to simplify square roots, we can use this multiplication property. We simply just need to rewrite the radicand as a product of the perfect square and something else. So going back to the square root of 54, like if I'm going backwards, I can be like, oh, well, 54 is 9 times 6, okay? And then when it comes to the square root of 9, the square root of 9 is 3. So it gets to come out of the radical. It's no longer inside of it, okay? So that's one way of simplifying square roots, is to use the multiplication property of square roots. It does involve you finding that largest perfect square factor right away. And if you can't find it right away, you can always make a tree diagram. So let's look at these two methods. So the multiplication property says I need to find the largest perfect square factor. So in the example, square root of 48, the largest perfect square factor is 16. So 48 is 16 times 3. The square root of 16 is 4, so it gets to come out of the radical symbol. 3 has to stay in. Okay, now in a tree diagram, this is what we can use when we don't identify that largest perfect square right away. Okay, so like 72. They're saying find the prime factorization, all right? So 72, like, I know that like 8 times 9 is how you get 72. Like that's what I had to memorize when I was younger. Okay, and so I would just continue to break this down because, like, yeah, 9's a perfect square, but I'm just going to break it down more in case you don't believe me, because 9 is 3 times 3. Okay, and then 8 is 4 times 2. 4 is 2 times 2. So I broke it down into the prime factors, okay? So I've got 2 times 2 times 2 times 3 times 3. That's where those all came from. Now, when you're working with squares, look for pairs and circle these. This is your buddy system. If a number has a buddy, it can come out and play, so to speak, okay? Because like 2 times 2, we know that's 4, and the square root of 4 is 2. So a 2 gets to come out. 3 times 3 is 9. The square root of 9 is 3. So a 3 gets to come out. So a 2 and a 3 both came out. We're going to multiply those together. That gives us 6. And that 2, that loner, has to stay inside. Okay, it can't come out and play. All right, so we end up with 6 root 2. So you can break these numbers down if that helps you. Maybe you're like, but wait a minute, 72 is 36 times 2. And if you had recognized that right off the bat, you would be using that multiplication property to get 6 root 2. So it's just like whatever's going to work for you, or whatever works for that particular radicand you're working with. you know? So if you want to pause right now and try examples 1 and 2, that's fine. I'm going to keep going, but if you want to try them first, you should do that. So the square root of 50, I look at that and I'm immediately thinking of money. 50 is 25 times 2. It's like 2 quarters, right? So then I'd want to take the square root of both of these because, let's face it, can't get any smaller than the square root of 2. Square root of 25 is a perfect square. It's 5. The square root of 2, that's all you can do. Okay. 98. Off the top of my head, the only thing occurring to me is 2 times something because it's an even number. So checking it out, I throw that in my calculator. I'm like, oh, it's 2 times 49. How nice is that? Because 49 is a perfect square. I could take the square root of each of these. Square root of 49 is 7. Square root of 2 is all you can do. Now in problems 3 and 4, we're going to multiply first, and then we're going to simplify, okay? Remember, when we multiply, we simply multiply insides with insides and outsides with outsides. So when I look at number 3, I have the square root of 8 times 2 root 5. So if I multiply my outsiders, well, there's only one of them, so I simply get 2. If I multiply my insides, 8 times 5 is 40. So that's my product. Now I need to write this in simplest radical form. So I recognize 40 as being 4 times 10. Now 4 is a perfect square. The question is, does 10 break down into any perfect squares? And the answer is no, it doesn't. It's just 2 times 5. Okay. So basically what I can do here is I can say that 2 root 40 is equal to 2 times the square root of 4 times the square root of 10. Okay, using that multiplication property to simplify here. The square root of 4 is 2. So now I've got 2 2's on the outside. I'm going to multiply those together. And I'm going to get 4. And the square root of 10 didn't have any buddies, so it has to stay inside. And then lastly, in number 4, the first thing I'm going to do is I'm going to multiply insides with insides and outsides with outsides. So 3 times 4 is 12. And then square root of 2, square root of 3, multiply those insides, you get 6. And that is your answer in simplest radical form. How nice. And so that's how we simplify radicals. You can go with the multiplication property where you find that largest perfect square factor right off the bat, or maybe you need to write out a factorization. What you do, what works for you, and that's how Backer breaks it down.